Module 2, Lesson 8, Dividing Fractions and Mixed Numbers. And mixed numbers are a whole number with a fraction. I can divide fractions by mixed numbers by first converting the mixed numbers into a fraction with a value larger than 1. So our strategy today is take these mixed numbers and make them fractions. And the value will be greater than 1 because we will have more than 1. And I can use equations to find quotients, and this is using the invert and multiply rule that we have worked on in the last lesson, lesson 7. So a quick review, converting mixed numbers to fractions. So I have 2 1/3. And we will frequently see students, or I see students a lot, that someone has shown them we just do this. And when I ask the students, why do you do that? They say, I don't know, somebody told me it would work. So I would like to take a quick moment and show using tape diagrams how and why this works. So here I have 2 wholes, and here is my 1/3. Now, because we want to turn this into a fraction, we want everything to be counted in thirds. Even these 2 wholes, we would like to have counted as thirds. So I need to divide my wholes into thirds. So I have 2 wholes. Each one of them has 3 thirds. So I wind up having 6 thirds. 3 times 2 gives me 6. 6 what? 6 thirds. I can then add to it the 1/3 on the side here, and I have 7 thirds. All right, looking at another example, 3 1/2. 1, 2, 3. I've got 3 1/2, and I'm going to make halves because the denominator is for halves. So here are my halves. Here are my 3 wholes. Here is my half. In my 3 wholes, I've got 2, 4, 6 halves. 2 times 3 gives me 6. And then I need to add my other half, which will leave me with 7 halves. 2 times 3 is 6, plus 1, 7. 7 what? 7 halves. All right, one last example, looking at 1 4/5. So I am making fifths. 1, 2, 3, 4, 1, 2, 3, 4. In one whole, I have 5/5, and then I have 4/5. And if I add them together, I will have 9/5. 1 4/5. 5 times 1, 5/5, plus 4, 4/5. Altogether, 9/5. All right, now that we've reviewed that, let's take a look at our goal today, what we're going to try to accomplish, dividing mixed numbers and fractions. So Carly has 4 1/2 walls left to paint in order for all the bedrooms in her house to have the same color paint. However, she has used almost all of her paint and only has 5/6 of a gallon left. How much paint can she use on each wall in order to have enough to paint the remaining walls? So she's got 5/6 of a gallon, and she needs to split it evenly amongst the 4 1/2 walls. And in my head, I'm hearing a partitive division question. How much is going to go in each group? Now, the strategy we're working on today is converting the mixed number to a fraction and then using our invert and multiply rule. So I've got 4 1/2, and 2 times 4 is 8, plus 1 is 9. So I have 9 halves. 5/6 divided by 9 halves. Now I'm greatly tempted to spend some time doing a model on this problem so that you can see why we invert and multiply. But rather than doing that, I would suggest that you go back and look at the video for lesson 7 so that you can see why invert and multiply works. So dividing by 9/2 is the same as multiplying by 2/9. And we have spent lots of lessons establishing that. So once again, if you want to know why that works, go back and watch some other videos. And now we've got a multiplication equation. 5 times 2 is 10, and 6 times 9 is 54. And we could say that we would put 10/54 of a gallon on each of the walls. Now, some people are going to be saying, but the fraction isn't in simplest form. You're right. The 10 and the 54 are both divisible by 2, so I can scale that down and have 5/27. So each wall is going to have 5/27 of a gallon. Just a quick look at the multiplication section here. So I have 5 times 2, and I could break the 6 here. I could factor it out to be 2 times 3, and then I could have the 9, and the 2's will divide, and I would have 5/27. I call that simplifying before multiplying, but basically what we're doing is we're dividing out common factors. So the whole walls are going to have 5/27, and of course this half wall is going to have half of that. So I would have to take 5/27 and find half of that if I were going to know how much to put on that half wall. Okay, taking a look at example 1b. This is just a straight up expression here, nothing fancy. We just need to calculate the quotient. So we've got 2/5 divided by 3 4/7. And our strategy today is to take this mixed number and turn it into a fraction. And so 7 times 3 gives me 21. Oop. Confused some poor student here. 7 times 3. So in 3 wholes, I will have 21/7. And I'm going to add 4 more 7ths, and I will have 25/7. So I've got 2/5 divided by 25/7, and I can use my invert and multiply. So 2/5 times 7/25, and 2 times 7 is 14, and 25 times 5 will give me 125. So 14/125. And as we start to look at some of these problems, we can see why modeling is not always the most effective strategy. The modeling can be good for helping us to understand why something works, but I can't imagine trying to draw 125ths to solve this problem. All right, so in class, you'll actually be participating in a memory game. So you will have a set of expressions that you will need to divide, and then you will match things up. You're going to simplify the expression, and you're going to match it to its simplified form. So for example, you will have a 2 plus 1, and you will have a 3, and you are trying to match these things together to make a set. So what I'll work through now are the different expressions that we have, quickly converting them to fractions and then completing the division. All right, so 3/4 divided by 6 2/3. I need to convert this to a fraction. 3 times 6 is 18, plus 2 is 20. So I've got 20/3. I've got 3/4 divided by 20/3. 3/4 times 3/20, and that will give me 9 80ths. All right, taking a look at the next one. 1/3 divided by 4 3/4. 4 times 4 is 16, plus 3 is 19/4. 1/3 divided by 19/4. 1/3 times 4/19. Now it's important that we recognize that when we use the invert and multiply rule, it is always the divisor that we are inverting. It is not the dividend, it is the divisor. And 1 times 4 is 4, and 19 times 3, what does that give us? A 57. 3 times 10 is 30, plus 27 more, 57. 4 57ths. All right, 2/5 divided by 1 7/8. I've got 2/5 divided by 8 times 1 is 8, plus 7 is 15/8. 2/5 times 8/15. 2 times 8 is 16. 15 times 5 is 75. 16/75. 7 1/2. 7 1/2 divided by 5/8. Nope, 5/6. I'm going to have to fix these slides here. 2 times 7 is 14, plus 1 is 15. 15 halves divided by 5/6. 15 halves times 6/5. I notice that I have a multiple of 5 and a multiple of 5, so I'm going to break the 15 into 3 times 5. And I notice I've got a multiple of 2 and a multiple of 2, so I'm going to break the 6 into 2 times 3. And I've got 2 times 5, so the 2's will divide, the 5's will divide, and I will be left with 9. All right, 3 4/7 divided by 5/8. 7 times 3 is 21, plus 4 is 25. 25/7 times 8/5. I once again see I've got 5's, so 5 times 5 times 8 divided by 7 times 5. These 5's will divide, and I have 40/7. And if I get really picky, I can turn that back into a mixed number, 5 5/7. All right, 5 5/8. 5 5/8 divided by 9/10. 8 times 5 is 40, plus 5 is 45/8 times 10/9. I can see that I have multiples of 3. 3 times 15. Actually, multiples of 9. I'm going to take that 45 apart, and I'm going to have 5 times 9. And I see I've got multiples of 2. 2 times 5. And the 8 is 2 times 4. So here's my 45, and here's my 10, and here's my 8, and here's my 9. But I have it set up so that these 9's will divide each other, and the 2's will divide each other, and I will wind up with 25/4. And 25 divided by 4, 6 times 4 is 24. 6 1/4, which is equal to 25/4. All right, 1/4 divided by 10 11/12. 12 times 10 is 120, plus 11 is 131/12. 1/4 divided by, and I've got 1/4 times 12, 131ths. This is a multiple of 4. 1 times 3 times 4. So here's the 1. And the 12 factors to be 3 times 4. And I've got 131 times 4. So these 4's will divide, and I'm left with 3 131ths. I'd hate to have to try and model these. Thank goodness we have some strategies beyond just modeling. All right, 5 3/4. So 5 3/4, which will be 4 times 5 is 20, plus 3 is 23. 23/4 times 9/5. Yeah, I'm not seeing much I can factor out there. All right, 23 times 9. 9 times 20 is 180. And 9 times 3 is 27, plus 27 will give me 207. 207 20ths. 207 divided by 20. Let's see, 10 times 20 gives me 200. 10 and 7 20ths. Once again, very grateful for strategies that don't always require models. I'm also glad that I understand why these strategies work. All right, 3 1/5. 3 times 5 is 15, plus 1 is 16/5, times 3 halves. Multiples of 2. So 2 times 8 times 3, and 5 times 2. So the 2's will divide. 8 times 3 is 24/5. 24 divided by 5. 4 times 5 is 20. 4 4/5. All right, 3/5 divided by 3 1/7. 3/5 divided by 3 1/7. 7 times 3 is 21, plus 1 is 22. 3/5 divided by 22/7. 3/5 multiplied by 7 22nds. Nothing I can simplify there. 3 times 7 is 21, and 22 times 5 is 110. 5 times 20 is 100. 5 times 2 is 10. 110. 21 110ths. All right, taking a look at K. 10 13ths divided by 2 4/7. 7 times 2 is 14, plus 4 is 18/7. 10 13ths divided by 18/7. 10 13ths multiplied by 7 18ths. I can see I've got multiples of 2. 2 times 5 times 7, and 13 times 2 times 9. So my 2's will divide. 5 times 7 is 35, and 13 times 9. For some reason my brain says like 107, but I don't think it's 107. I think it's 117. 13 times 9, better check my work here. 9, yep, 117. 35 117ths. All right, one last exercise. 2 1/4. 4 times 2 is 8, plus 1 is 9. 9/4 divided by 7/8. 9/4 times 8/7. I see I've got multiples of 4. 9 times 2 times 4. The 8 factors out to be 2 times 4, and I've got 4 times 7. The 4's divide each other. 9 times 2 is 18/7. 18 divided by 7. 2 times 7 is 14. 2 4/7. So in class, you would complete all of these, and then you would play a matching game with a neighbor. All right, so how does the process of dividing a fraction by a mixed number compare with our previous work with division of fractions? Well, they're pretty similar. We can use the invert and multiply method for both types of problems. One difference is we do have to change those mixed numbers into fractions so that we can work with them. So taking a look at the I can statements, this is kind of our last lesson learning about dividing with fractions. I can divide fractions by mixed numbers by first converting the mixed numbers into a fraction with a value larger than 1. And I can use equations, our invert and multiply rule, to find quotients. Now, it's important to remember as we conclude Chapter 8, as we kind of wrap up our dividing fractions section, that there's a reason that this works and that we need to be able to reason our way logically through what's happening. We've taught and practiced a lot the different meanings of division. I know in the classroom that was an eye-opener for many students that there were 2 meanings for division and that we can represent those and we can think about what's happening as we work with these problems. So don't be quick to forget all of the good learning that's taken place as we've worked towards the invert and multiply rule and being able to apply it. So this concludes Module 2, Lesson 8. If you've got questions, make sure you talk to your teacher and make sure you complete your problem set, and good luck on your activity.